Hi everyone, today I want to talk about type inference around tuple type families. So you might know, and if you don't, I'll link to you in the description. I've recently put out a proposal for an opt-in. Let me just repeat that: opt-in, optional, new syntax for lists and tuples. This is the result of long conversations, actually, because the current syntax for lists and tuples are punned, which means we use the same notation in types that we do in terms. And this is both confusing to people learning the language and also sometimes confusing to GHC because as we start to mix types and terms a little bit more, it can be harder to remember what the rules are for when we're in a type versus when we're in a term. So it might be nice to have different names for the types. By the way, what do I mean by punned here? Did I use that word? I don't remember. We call this a pun, right? Because I can say something like x is a tuple of an int and a bool, and then at the term level, I'm going to use the exact same notation with parentheses and commas. And so that means, though, is that when I see something like this, am I talking about the type of tuples, or am I talking about the tuple that contains two elements, one of which is int and one of which is bool? It's a bit of a confusing distinction. I can't even talk about it very well because of this this funny notation. And so we're trying to clear that up. And that's what the proposal does. And it does so by defining types that look like this. So we have tuple2 equals, well, the term level notation is going to be the same. So I could write this, but that's not going to parse. GHC can't make any sense of that. But we're going to have a whole bunch of types that look like this. Again, that's not going to parse on the right-hand side, but the term level notation to be able to construct a tuple2 or a tuple3 is going to be just the same thing that we have today. Again, totally opt-in. You can continue to use the old syntax if you want to. The question I want to address today is, can we avoid writing that little number there? I don't want to write the 2 or the 3. I just want that to be inferred. And so can we do that? So I'm going to get rid of this, and this proposal isn't implemented yet, and so I'm going to have to continue to use this old tuple notation. So the idea here is that I want to write a type family that kind of looks like this. I'm going to call it tuple n because it works for any n. And then I don't know what I'm going to put there. And so tuple n of, well, nothing, that should equal unit. And tuple n of just one type, we'll just say A here, that's going to be solo A. So solo actually already exists in GHC, and it has a straightforward definition like this. So we could say that, and then tuple n of AB equals the tuple containing A and B. Tuple n of ABC is ABC, things like this, right? And I want to be able to write this for all the different tuples. GHC actually already has a hard limit of 64, so we could write all of these out. I'm not going to go any higher than this. So already, though, in writing this, I have a problem because a type family is supposed to have a fixed arity. Unlike sort of term-level Haskell functions where we might, through sort of writing lambdas out and other tricks, we might have various different numbers of arguments, a type family has a fixed arity. So we can't have tuple n that has all of these different arities. Here it has arity 0, here 1, here 2, here 3. So that's already out of the question. But I think about this, and I can actually rewrite all of this. So instead of writing A comma B like this, I can write that. I can actually do that today. That's fine Haskell today. And instead of writing it like this, I can write this. So these tupling operations can already be written prefixed like this. And now I see I can simplify some and just get rid of these repeated arguments. Okay, so now I fixed the arity problem, and instead I'm left with two other problems. One is that tuple n, it looks like all of these equations, it looks like all sort of are the same nonetheless. So how am I going to choose which one? Which is related to my other problem, which is the kinds of all of these things are different. So at this point, I think it's helpful to whip out GHCI. Oh dear, that's from a different video. Let's just get rid of that. I don't want to be here at all. I want to be, where do I want to be? 1228. Okay. So let's see here. I'm going to launch GHCI. And I can get the kind of these different things. So I can ask, what is the kind of this? Well, it takes 2 types and returns a type. What's the kind of this? It takes 3 types and returns a type. Okay, so these have different kinds. Of course, in more modern GHCs, we write star as the word type. And so all of these right-hand sides have different kinds, but they all follow a nice little pattern. So what I actually want to say here is that the type tuple n, its kind is going to be, well, it's going to depend on some n. So we're going to have this for all n, and it's going to be a natural number. And for each n, we're going to get a tuple n kind n. Okay, well, what's tuple n kind? And then I can get rid of the ... Okay, so we're starting to make some progress here. So, but we have some extensions to add. So let's add some extensions. So I want explicit for all. That's going to fix my for all. Then, oh, I need standalone kind signatures. Sure. And then polykinds. Absolutely, I need polykinds. And then not in scope. Okay, that's easy to fix. I can say import ghc.typelets. Let's leave a little bit more space for code here. And TupleNKind, well, that doesn't exist yet, so let's write it. That is itself another type family. Because it has to compute, it has to take this nat and then compute what the kind of the right-hand side should be. And so we can do type TupleNKind. This is going to take in a nat and it's going to return a type. And it's a type family. So here, let's see, TupleNKind of 0. Well, that means there's 0 arguments, so that should just be type. And if it's anything other than 0, it has to be greater than 0 because it's a natural number. So n here, this is going to be type arrow TupleNKind of n minus 1. Okay, so now a bunch more errors. Let's see here. Not in scope. Well, let's bring that into scope. Import data.kind. Now what? Now, illegal operator use type operators. Well, that's easy enough. Type operators. Okay, and then now what? This, oh, data kind. Yes, yes, yes. Data kinds. Okay, now what is it complaining about? Oh, illegal type family, because I need type families. Now what? Undecidable instances. Well, that's because GHC can't figure out that if we keep subtracting, we'll eventually get to 0. So we turn on undecidable instances just to get rid of that error. And then, oh, now we have bugs down here. Expected kind TupleNKind n0, but unit has kind star. So the problem here is that from this, I know that the expected result type is going to be type. I know that the expected result type here is type arrow type, but we can't use that to infer the n. So really, I need this to be an injective type family, where we say that the result determines the input. And of course, that's not allowed without yet another extension. So let's turn that on. Type family dependencies. Okay, so now down here, type family equation violates the family's injectivity annotation. And the problem is that the GHC doesn't know that subtract by 1 is an injective operation. It is indeed an injective operation, but GHC does not know that. There's some funny business maybe around 0. I don't want to think too hard about that. Instead, I'm just going to modify this not to use the typelets natural number here, but instead one that I roll myself because it turns out to work better. So if I write data nat equals 0 or suck nat, let's see here. And now down here, I can change this to 0, and then this becomes suck n. And then now I can just write n here, and then this is more obviously injective. And aha, this works. Oh, what unnecessary thing do I have here? Oh, may require blah, 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 blah. Extension type operators is not used, and type families is implied by type family dependencies. I don't want to deal with any of that stuff. But I can't stand having that blue squiggle. So, oh well, we'll just do that. I may have to reintroduce these. Okay. Great. So now we have this tuple n. Does this actually work? Yes, it does. So I can take a function here, let's say that is tuple and int bool, and have it return int bool. And what does it do? Well, it doesn't have to do anything because this reduces to this tuple operator applied to int bool. Aha, it all works. And I can just add another one. And here, that doesn't work because it's not the same on both sides, but now it works again. Excellent. I want to take this one step further. Maybe it's, I don't know if it's one step or not. So actually, I'll admit, everything I've done so far, I sort of knew was going to work. I had done this previously. But now this next step, I actually don't know what's going to happen next. And that is, I want to do the same thing for unboxed tuples. So an unboxed tuple can contain unboxed types. So here, we've seen the kinds for the tuple things. An unboxed tuple has hashes instead. And so if I ask for this, oh, now we need a little bit more space down here. So it says that it takes types, but that's a lie. It doesn't. And that's because I need to turn on print explicit runtime reps. If anyone's seen the movie Interstellar, you might remember that the robots in Interstellar have an honesty setting, which you can change up or change down depending on how honest you want the robot to be. GHC starts out with sort of a medium level honesty setting. And sometimes we have to turn on fprint explicit this and that to get it to be a little bit more honest. That's what I'm just doing here. And I say, I really want the full glorious kind of an unboxed tuple, not this simplified one. So the full glorious kind looks like this. It takes this has 2 commas, so that means there's 3 different components here. The first one is of any runtime rep K0. This has any different runtime rep. This has any different runtime rep. And then it's going to return one that has a tuple rep where each component is represented has the representation according to one of the arguments of the tuple. This is sort of the definition of what tuple rep really means. I have other videos talking about levity polymorphism that this connects with. We don't really actually need to get into all that much about levity polymorphism other than the fact that we have this rather glorious kind here, and we need to take that into account when trying to make a tuple n operator for unboxed tuples. So if I have only 1 comma, then there's only going to be 2 input types, and then here this tuple rep just contains K0 and K1. So the challenge is, let's get rid of this friend. The challenge up here is to make a tuple n hash, that behaves this way. So let's think about this. So tuple n hash, what is its type? Well, let's just follow on from what we did before. For all n nat, tuple n kind hash n. Okay, that can't be wrong, can it? I haven't really even said very much, except that here, operator applied to too few arguments. This hash at the end of a name is only allowed with the magic hash extension. It's used for sort of low-level things that generally users won't have to experience. But here, we're defining a low-level thing, and so we want that hash there. There's nothing more to the hash other than sort of a convention that you can put the hash at the end of a name. It doesn't actually do anything other than part of the name, but it's the right name that I want here. Let's see, the standalone kind signature lacks an accompanying binding. Well, yes, it does. And also, this is out of scope. So let's actually work on that second problem first. Here, I can fix the first one quite easily. Whoops, I don't want it to be a type. I want it to be a type family. So here, tuple n kind hash. Let's see if this works out at all. So what is this going to be? So type tuple n kind hash. What's its type? Well, it takes a nat and it's going to return a type. And then type family tuple n kind hash n, where tuple n kind hash of 0. Let's see, what's that going to be? Well, that's going to be type of tuple rep of the empty list. I have to put a little tick there to say it's the term empty list, not the type empty list, right? This is the confusing thing about puns. Okay, so now there's a bunch of things that aren't in scope. If I import ghc.ext, more of them will be in scope. Oh, all of them. Haha, good. Okay, so it's happy with this. Can I write this out? Tuple n hash of, well, equals, what do I want to say here? Equals the empty unboxed tuple. Does this actually work? No, something has to be wrong somewhere. That's red. What does that mean? I don't even know what that means. Ah, now I have a bug. Operator applied too few arguments. Oh, I turned on magic hash, but I have not turned on unboxed tuples, which I will need. And now down here, expected kind TupleNKind hash n0. Oh, this is the same thing. We know what kind this should have, but that doesn't inform n because we forgot our injectivity annotation. So let's put that on. And ooh, we've turned green. Okay, so that worked. Excellent. So let's try tuple n hash equals solo hash. So we need to know what solo hash is. Not in scope, solo hash. Perhaps you meant so. You know, I'm on GHC 8.10.7. The solo hash might have been a 9.0. Let's just skip the solo hash because I can't define it myself. But we can certainly use this. So now, expecting 2 more arguments to this because, well, that's actually kind of a bad type error. Expected kind TupleNKind hash of n0. So I have to extend my TupleNKind hash to deal with things that aren't 0. So suck n is, well, now I'm a bit stuck. Up here, I could just say type, but I don't want type. I need some sort of type of rep goes to type of, well, it goes to TupleNKind hash of n or something like that. But now everything is no good. This is no good because I have no way of sort of relating all of these things. The problem is, as I'm sitting here, TupleNKind hash, it can't be described by a nat. It has to instead be described by a list of runtime reps. Okay, and so here, the base case, TupleNKind hash 0. Well, wait a sec. It needs to be, I want something like this. So we have type rep here, and then this has to be TupleNKind hash, and we need to remember the rep as we're going down, but we have sort of n more things to do. Maybe it needs both a list of the things that have been encountered so far plus the number of things that haven't been encountered so far. That seems plausible. And I'm just going to comment this piece out because I don't want errors from here while I'm working on TupleNKind hash. And let's also get rid of this injectivity annotation because I don't want errors around that quite yet. So this is like reps already seen, and this is n to go. So now here, if I have TupleNKind, so this is reps already seen, and if there's no more left, then indeed this is going to be something that looks like this. Now, if I have suck n, and then this is also reps that we've already seen, then we have some new rep. Oh, no, but this one is unbound. So it can't just sort of accumulate up. It has to be all reps, not just reps already seen, but this has to be all reps. So when we call TupleNKind hash, we have to pass in all the reps all the way up front. And then here, but now we need all reps, and really we need reps to go separately so that I can pull off the first of reps to go. So tuple reps, and then the number of reps to go is going to be empty here, but then the result is going to be all the reps. Let me keep my naming convention. And then TupleNKind hash here. So that has to take all reps and then first rep and then more reps to go. And then down here, this is really the type first rep. And then this is going to be all reps to go n. Oh, and then here, of course, this is all reps. Okay, that looks maybe plausible. I don't know. Will it work? Who knows? But let's load this file. What is this called? Tuple.hs. Oh, it doesn't like this. Because I need type operators back. Sometimes HLint is a little bit annoying. Type operators. Oh, now what is it complaining about? Unboxed tuples is not used. Well, it is now. Okay. let's see here. So let me try to load that again. Aha, excellent. So now I can use the kind exclamation point operation in GHCI to, let's see, I want to know what the kind is of tuple and kind hash of, I don't know, lifted rep, and then I'm going to pass these again because we're sort of on the outside here. And then this is going to be 2. Not in scope. Well, that's silly. Import ghc.ext. Oh, we need to set fprint explicit runtime reps, although I thought I already did that. And it's still, oh no, lifted rep. Haha, it really is star. Let's try something more exotic than lifted rep. That was a bit silly of me. Let's do unlifted rep and, I don't know, int rep. Int rep, by the way, is not the representation for int, it's the representation for int hash. Again, not all that important to note deeply about levity polymorphism. Excellent. This is exactly what I wanted from TupleNKind hash. So let's see now, can I write tuple_n hash? And now this is wrong. Really, we need for all reps, and it's not nat anymore, but this is going to be, let's see, a list of runtime rep. And now I want to call TupleNKind hash with reps, because they're all left to go, and then the length of reps. So I'll need to define length, but this can be over any list. So type family length of x's, where length of the empty list is, of course, 0, and length of anything else is the successor of the length of the tail. Okay. Let's see now. So here, expected kind TupleNKind hash blah, but it really has this other thing. And now we're back to injectivity. Before playing with injectivity, let me just put in on the left-hand side what I want the reps to be. So in here, the reps are actually empty. And, oh, what is this complaining about? Parse error. Aha, I don't have type applications on. Oh, now what? Extension type applications is not used. Oh, that's because I have a bug down here. So let me fix this. Expecting 2 more arguments to blah. That's because injectivity still isn't working. So here, this is going to be a list of rep 1, rep 2, where those are variables. And I think that should work. Does it oh, now what? Now what? Extension type applications is not used. Oh, but yes, it is right here. Oh, HLint, you have a problem, Mr. HLint. Okay, so I will post that problem to HLint later. Okay, let's see here. I recognize HLint is. Who knows if HLint is a mister? I should not have gendered that. Let's move on from that though. Let's see. TupleN hash is this. Oh wait, it's working. It's working. I got myself so distracted by HLint, I didn't even get to celebrate that it's working. But now let's see, can we get rid of this extra little bit here like we were able to earlier? I bet we can. And this is actually going to be important for practical uses of it, right? If I have f takes tuple n hash of int hash double hash, and I want that to return the unboxed tuple. Is this good enough? I doubt it. No, it's not. And that's because it's not quite clever enough to figure out what the kind of this thing is without that injectivity. So let's see if we can figure out the right injectivity annotation here. So does the result determine all reps? I think it does, actually. Quite straightforwardly. Is that enough? That should be enough, I think. Expected this, but TupleN hash has that more glorious kind. Let's see. Can I just add more injectivity things here? And will that just work? It might just work. Wow. I guess this is fully injective in all of its arguments. That's convenient. But why doesn't this work now? I would expect this to work. but tuple n hash has kind TupleNKind hash of listy thing, length of listy thing. Yes, it indeed does. That should be enough to reduce TupleNKind hash to something more reasonable. Why isn't this actually working? I think that this should actually work. Okay, let me comment this out so I can load this into GHCI. So kind hash of tuple n hash int hash double hash. Let's see. It has kind this. Oh. It doesn't know. Maybe there's more reps to go. But here, I know by the fact that I've used it in a function that it should be a type of something. So here I can do this for all output rep. This has type output rep. And maybe that's enough. Oh, not in scope, type variable. But I said for all out. Have I misspelled something somewhere? Oh, no, maybe the, it's my colon operation was, it bound too loosely. Let's try this now. Okay. Expected. Well, blarg. Expected kind this, but tuple n hash has that kind, but I'm trying to tell it that I want it to check it against this type business, which should be enough to say that I'm in this case. Why is this happening? Need to think. Cannot talk while thinking. Thinking didn't yield all that much, but let me try another experiment here. Let's see if I can take TupleNKind hash of all of these arguments, exactly as written here. I need to bring reps to go into scope like this. And then I want to see, does this reduce? I expect it to. I want it to. Oh. Lots happened there. I think that copy and paste just failed. Yeah, it did. Okay. So I want kind of that, and then same thing. I don't really need the ticks though. Int rep double rep reps to go, and then length of lifted rep int rep double rep reps to go. Be nice if I got matching on parentheses, but I think that that's oh no, I need another close. Okay, so that's what it's trying to do, and that, let's see, so it equals type of lifted rep, that's what this is, then this to TupleNKind blobbity 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 blah blah blah. So it does reduce. It does reduce. Now let me think again. Still a little mystified. Let's keep debugging. Here we have tuple n hash. Let me just see what happens if I sort of don't want to do this, but if I pass in the right arguments, does that work? Is it really just about inferring that? Yes, it is. Oh, but now here, of course, id can't work over strange unlifted things, so I just have to write fx equals x. Oh, but there's that x that's in scope up there from, let's just not get involved with that. Oh, and this still has trouble. Why has that type? Couldn't match tuple n hash. Oh, well, I don't have enough cases here, so let's just add that. Okay, good. This works. Was that the problem the whole time? Oh. Maybe you all saw that, and now I've wasted a bunch of your time. But I'm not going to edit all of that out, because maybe it's helpful for you to see that, I get caught by stupid things too. We all do. Oh, but now instead of being upset, I should be happy. Green. Look at that. We have tuple n hash, and it's working all the way. It's just doing the thing it should do. Now I think I can actually even get rid of these little bits on the left and leave it for GHC to be clever. Oh, no. Somehow that did not work. Here, now it's having trouble again. Why is it having trouble? I should think that it would be able to figure this out, because here, TupleNKind hash, we know what the type of... I think it should be able to do this. Do I challenge myself to figure out why? I mean, newer versions, or GHC 9.4 or something, there's a proposal on the table that will forbid this kind of casing based on the right-hand side of a type family anyway. So you'll have to write the thing on the left. But I still think that this should be able to be inferred. So, okay, so let's get rid of this so I can load it into GHCI and play around with it a little bit. Because we're not quite done yet, evidently. So here, let's see what happens. First off, tuple n hash of empty. So I can write that like this. Whoops. Okay, so that worked. Now, if I ask what's the kind of tuple n hash, or what's the what happened when I reduce, and now let's be concrete. Tuple rep, int rep, double rep, expected kind. Okay. Oh, but that's wrong. I need this to be, this should be type of int rep to type of double rep to that. And so it doesn't reduce. I wanted to see some commas here. So that is somehow not working. And when I had this bit up here, let's just check this out. If I put in this rep1 and rep2 thing, and then now reload and then try it, now it does reduce. So somehow that piece there is making a difference. What I want to know is how is GHC even understanding this definition? So I should be able, if I set print explicit kinds here, and then dedump types maybe, and then reload. Let's see, we get axiom, the axiom for tuple n hash. So here, empty list reduces. Now here we have, oh, GHC, you're being very silly. This is a known bug, actually. I see what's going on. So what's happening here is that because I haven't said what the representation should be, GHC very enthusiastically wants to default these representations to lifted rep, because that's what most people mean most of the time. And so when I don't explicitly make it a variable, it will desugar that line into this. So it's a little hard to read because this is a manual application of cons with all of these kind arguments in here. But this is a list containing lifted rep and lifted rep. And so this will only reduce when the left-hand side, when the types are lifted rep and lifted rep. But of course, that's not the general case. So I'll have to put in my rep1 and rep2 business over here, and then here we'll need rep1, rep2, rep3. And now everything works. We're green. Am I still getting warnings up here? Oh, I am, because of that. Ms. H-Lint is mad at me up there. But here we were able to do it. So that means that I can take this idea and incorporate it into the proposal, and now we can have tuple n hash for people who want that. So I hope this has been interesting. You got to see a little bit of some type shenanigans, ways of running into problems, solving problems, all that fun stuff. Thanks for watching, and I hope this was fun. Bye.